Hi, I'm Amy Suggs, and today we are going to cover section 1.2, which is basics of functions and their graphs. We're going to cover this section in 3 different parts. So here's the first part. We are going to cover relations. Relations are a set of ordered pairs. Relations can be represented as a set. They can also be represented as graphs and mappings, which we'll look at in a minute. Within relations and graphs and mappings and all sorts of things, we have domain and range. Domain is the input or the set of x values, while the range is the output or the set of y values that we will look at. So to take a look at what a mapping and a set would be, to give you an idea of what that is. For a mapping, we might list the domain and a range in just a list in a column. So in the domain here, I'm going to have 3 names. I'm going to have Kate, I'll have the name Jim, and Dave. And those are going to be the elements that are in my domain. In the range, I'm going to have some numbers, and I'm going to say that those are corresponding ages to the people that I have listed in my domain. For the mapping, the way this works is we're going to draw arrows, and that's going to let you know which value of the domain goes to which value in the range. So Kate is paired with 5, Jim is paired with 7, and Dave is paired with 6. And that's just what a mapping is. It's a different way to put together your values in the domain and range. If I put that as a set is always contained in the braces, which are the squiggly lines. My ordered pair, I'm going to have Kate, comma 5, because with any ordered pair, you're going to have your X and your Y. So then I'm going to have Jim. Jim goes with 7. And last I have Dave, and he is paired with 6. And so that is another way to represent my relation. So just to make sure you remember, all ordered pairs are given as coordinates. We have the x coordinate, the y coordinate, and so you always, whenever you look at a point, you always know which value is in the domain and which value is in the range. That never varies. All right, so let's look at some different relations, some different sets. If I'm given set A, here I have the points, the ordered pairs, 2, 4, 1, 5, 9, negative 3, and 2, 7. What is the domain of the relation? So what I want to do is I'm just going to list the elements. Once again, when we list them, we're going to do so in sets. A few things you want to make sure that you don't repeat any of your values. It's unnecessary if you have multiple values or any values that are the same in the domain. You don't need to repeat them. Also, order doesn't matter. We get used to writing things smallest to largest. That's perfectly okay. But really, when you have a set, you're just listing the elements, so the order makes no difference. So for set A here, I'm just going to list the elements of the domain. So first one, my x here, I have 2. The second point has an x value of 1. The third one, we have 9. And last is 2 again. So like I said, I'm not going to repeat that. I'm just going to stop there. And that's going to be the domain of that particular relation. For the range, what I want to do is exactly the same thing. You list it as a set. We're going to look at the y values this time. So for the first ordered pair, we have 2, 4. So 4 is going to be the y value. Then in the second ordered pair, we have 5. The third ordered pair is -3, and last is 7. And so that's going to be my range. So let's look at another one. If you want, you can stop the lesson. You can try this on your own and then come back when you have your answers and compare them to what we have. Okay, so what is the domain of relation B? I'm going to set up my little set. We look at the x values. We have -2, I have 0, and 4. That is going to be the domain of my relation. For some reason here, I have B, and that's not what I want. So let me go back and put D for domain. In the range, well, the only value that we have in the range is 3. That's the only number. All 3 points have the same value in the range, so we just put that value in there one time. We don't repeat it. Okay? So finding domain and range of relations isn't bad. You just make sure you know which value is the x and which value is the y, and you can put it accordingly into your sets when you find them. Next, we want to go to finding functions. What is a function? We can use relations to identify functions. We will also look at equations as well as graphs. Now, by definition, what a function is, every value of the domain is paired to exactly one value of the range. What I have here is a few different variations of that. This means that every value in the domain occurs only once, so no x value can be repeated. Also, for every input, there is only one output. Those are slight variations that might help you to come to an understanding of what a function is. The first thing I would like to look at is the sets that we just went through. Relations are an easy way to get started on whether or not we have a function. So do the sets represent a function? To repeat the definition, every x value does not repeat. It occurs only once. So what we want to do with these relations, I want to look at them and say, okay, do we have a function? Well, for set A, we have 2, 1, 9, and 2. So what I'm looking for is whether or not we have all unique values in the domain or if we have any repeat values. And then for set A, you see that the value of 2 repeats. What this means is this is not a function. This set does not represent a function. Anytime that happens, that's the case. Then if we go to set B, we have -2, 0, and 4. Each of those are unique values in the domain. So what we're given here, set B, does represent a function. So I'll just say is a function. All right. And so with the relation, it's really nice because you're able to see all of the values in the domain. You're able to see all of the values in the range. You can just pick out the points. We are not concerned with the y values at all. You're only focusing on the x here with the sets of ordered pairs. Next up, we have graphs. When we're given the graph of an equation, and we want to determine whether or not it is a function, we have something called the vertical line test that allows us to determine whether or not the graph represents a function. We pass a vertical line through the graph at different points. If the vertical line hits the graph more than once, then it is not a function. Remember, we can't have any particular x value occurring more than once. So if a graph uses an x value more than once, it's not a function. Now you could do something like sliding a piece of paper across the graph. It's as easy as just drawing lines. And hopefully you're using a ruler. These are not very straight. Maybe if I use a piece of paper, that will help me to guide. There we go. So as you can see, drawing multiple lines through this graph, each vertical line hit the graph in only one spot. So because of that, this particular graph passes the vertical line test. Therefore, this graph is a function, or we would say it does represent a function. If we go to the second graph there, I can draw a vertical line. Let me get my straight line out. As soon as I draw that vertical line, you can see that it hits this particular graph more than once. If that occurs in any one location, this particular graph fails our vertical line test. Because of that, it is not a function. Okay? And that's what the vertical line test does. Once again, it's all about the x values. Does the x value occur more than once? And that's going to tell you whether or not what you have is a function. The third type of example that we have are the equations, and those are a little bit different. When you're given an equation and you're trying to determine whether or not it's a function, still by saying the definition, there may not be more than one value for an x, or the equation is not a function. So when we're looking at equations, we're going to be doing the same thing, but we're kind of think about it in a different way. We're going to say, if we have a particular x value, is there going to be more than one y value paired with that x? That's what we want to determine. So let's look at some equations. I'm going to start off with a pretty basic equation. I have x plus y equals 5. What we want to do is to solve for y. That's your first thing. So here I need to subtract the x from both sides, and then I have y is equal to 5 minus x. Next step is to pick an x value. Any x value will do, but you don't need anything huge. I'm simply going to go with x equals 1. I'm going to substitute that in. Y equals 5 minus 1, or y is equal to 4. What that means is that if I have x equals 1, then I get from that equation y equals 4. I have one y value corresponding to that particular x value. As long as you only have one y corresponding to that x, this equation is a function. And that's what we're looking for. Now you might say, well, how do you know if I come up with two different y values? Well, let's do an example so you can see. If we are given the equation x plus y squared equals 5. I'm going to go through the same process. We want to solve for y. So I'm going to have to subtract the x from both sides, move it to the right side. Now what we have here is we have y squared. Well, I'm still solving for y. In order to get rid of that square, I'm going to have to square root both sides. Remember, you do the inverse operation when you want to get rid of something. So the squared, that exponent, and that radical are going to undo each other because they're inverses. What we're then left with is y equals plus or minus the square root of 5 minus x. Remember, when you use the square root property to solve, you always introduce the plus or minus, because when you square a positive, you get a positive. When you square a negative, you also get a positive. So you have the possibility, the two different solutions. So we have plus or minus 5 minus square root of 5 minus x. So if I go through and I say let x equals 1 again, and I substitute that into my equation, I have 5 minus 1 which is going to give me plus or minus the square root of 4. Square root of 4 is 2, so we end up with plus or minus 2. What that means is that if x is equal to 1, y is equal to positive 2 or negative 2. So when y is 1, it is paired with more than one y value. It's paired with positive and negative 2. So now we have a repeat x, our domain, so that implies that this equation is not a function. Anytime you have to square root, you end up with a plus or minus. Okay. So it doesn't matter what x values, again, you're not trying to, graph this. You are just trying to determine if you're coming up with a function. That's why any x values will work. So let's do one more example. Let's look at x squared plus y cubed equals 9. So we need to subtract x squared from both sides. And this time, since I have the third power, the inverse of that will be the cube root. Got to make sure that it matches. Now I want to make sure that my little exponent is with the x. So my third power and my third root are going to undo each other, so I'm going to get y equals the cube root of 9 minus x squared. Now, do we have a plus or minus with a cube root? The answer is no, we do not. When you take the cube root of a negative number, you get a negative number. When you take the cube root of a positive number, you get a positive. Simply one answer, which we'll see when we finish this example. I'm going to go through again and stick with x equals 1. It's a nice little number. Substitute that in, cube root of 9 minus 1 squared. 1 squared is just 1. So that's 9 minus 1. 9 minus 1 is 8. And the cube root of 8 is simply 2. So when x is 1, I get one y value of 2. Therefore, my x value does not repeat, and this equation is a function. It does represent a function. Another way you could do this is you could always graph these equations and take a look at them. That works also. Your general rule, if y has an even power, when you solve for y, you'll end up with more than one value due to the plus or minus. We talked about with the square root property how you end up having to plus or minus when you introduce the square root by using that method. So any even power for y is going to make that happen. Whether it's y squared, y to the fourth, they all follow the same thing because it's an even root. So if you have y to an even power, it will not be a function. Likewise, if y is an odd power, then the equation will always be a function. Okay, even power, not a function. Odd power is a function. So that's something that can also help you out too. You can look at the equations. I would still recommend graphing or going through and solving for y so that you would, make sure that you did it correctly, and then you would know whether or not it truly is a function. So that is going to conclude it for this section. I will see you in part 2. Bye.